Okay, so this is the 2016 Junior Physics Olympiad, okay, question 44. So two biconvex lenses, actually thin converging lenses, okay, focal length 15 cm and 10 cm are placed 20 cm apart. And object is then placed 25 cm away, which is here, from the 15 cm focal length lens. Okay, and what type of image is formed and what distance is it from the second lens? Now, this is actually related to your O-level thin converging lens. So from there, we need to know the concepts, which is that for converging lens, this is the optical center. So any ray that passes through optical center will continue going straight. Okay, and any rays that goes horizontally, okay, let's say horizontal here, it will then cut through the focal point. So let's say this 20 cm, right? Let's say our 15 cm is about here. Okay, so about there. So it will cut through the focal point. So we should expect it to then cut through. Okay, so as it cuts through, now let's ignore the second ray first. Okay, let's ignore this the second lens first. Okay, we ignore that it's there. Okay, let's just focus on the first lens. Now, if it's just the first lens, this ray, okay, this is not that straight. Let me redraw this part. So this ray will then pass through, okay, and continue going straight to form an image at this side. Okay, so we get an image here. So this is the image form if there was no second lens. Okay, if there was no second lens, this image will be formed here. Now, what happens if there was this second lens? Okay, so let's say that, okay, without this second lens, okay, let's consider without this second lens. Now I'm interested in this second optical center here. Now, there will be a point, there will be a ray, right? Let's say without this second lens, there will be a ray that will actually go to here. Okay, it will actually come from here, straight, all the way to the first lens. This is the ray that will have come from here. Okay, so this ray, this red color ray now, with or without the second lens, it will still go to here and come to here. Okay, we just because with or without this lens, there will be a, without this lens, right, there will actually not be here. So we can treat this red color as an imaginary ray that if we extend this particular first lens, right, if we extend this, it will also go through this red color and it will reach the same point. Okay, now why do we want this? It is because now we can put in the second lens with or without this second lens, as long as we extend this particular lens. Okay, we extend this particular lens. With or without this second lens, this red color ray will still move through the same path. Okay, so because it moves through the same path, now comes the interesting part. We know that this red color ray, right, will always be there. Then now we need to find a second ray that will have moved through this, that will cut and give us the real image. Now, there will be definitely another ray. Now, this time I use green color. Let's say there is a certain spot that it cuts, okay, 15 cm, maybe somewhere here. Okay, 15 cm is probably here, okay. So this 15 cm. And our ray will then cut through. Now, any ray that cuts through this focal point, when it reaches the lens, it will be horizontal. Even though this lens is not well drawn, okay? If I extend it, it will be horizontal. Now, the moment it goes horizontal, when it hit this, it will go back to cut the focal length. So this is about 10 cm here. This length is 10 cm. And this ray will then continue to go in this direction. Okay, so it goes down, horizontal parallel to the principal axis, and then go back up and cut the focal point again. So the point, so this red color rays, right, and the green color ray, with the first converging lens, they will confirm bend in these two directions. Here become horizontal, here become going down. And when you put in the second lens, the red color continues, and the green color will bend towards the focal point. So the intersection, the actual two rays that are happening now, okay, they're going to be here and going to be here. So this gives us the final image. Okay, it will be here. The image will be here. Okay, the actual image, maybe I make it. Okay, the actual image will be in this direction, this one. And you can see that this is actually less than 10 cm. And because it is converging, it's not dotted backwards, this is going to be a real image. So we have our characteristics is being real, and the object distance must be less than 10 cm. So when you look through all the cases, real and less than 10 cm, only answer A is the answer.